When the temperature of a substance is increased, its particles jiggle faster and move farther apart on average. The substance undergoes expansion. With few exceptions, all forms of matter, solids, liquids, and gases, expand when heated and contract when cool. Here's a weight hanging from a length of wire. When the candle is moved along the wire and heats it, what happens to the height of the weight above the surface? That's right. Due to thermal expansion, the wire lengthens and the distance between the weight and the surface decreases. Similarly, what happens to the sag of overhead electric wires on a hot day? We see the wires become longer, which is why they sag closer to the ground. Or what happens to railroad tracks on a hot day? Again, thermal expansion occurs. Unless proper precautions are taken when laying the tracks, expansion in extra hot weather can result in unwanted buckling. Different metals expand differently. Brass, for example, expands more than iron for an equal increase in temperature. This proves useful when thin strips of brass and iron are welded or riveted together, making up a bimetallic strip. When the strip is heated, the brass side becomes longer than the iron side, which bends the strip. Or when the strip is cooled, bending is in the opposite direction. Bimetallic strips are used in oven thermometers, electrical toasters, and various devices. Let's return to the ball and ring question of the previous lesson. Here Annette Zetterberg intrigues her class with this favorite demonstration. When the metal ball and ring are at the same temperature, the ball can pass through the ring. If she heats the ball and asks if the hot ball can pass through the ring, most students give the correct answer, no. The ball expands and no longer fits. But if Annette instead heats the ring instead of the ball and asks if the ball will pass through, the class response is mixed. What's your answer? I think you agree the ring will expand when heated, correct? That means it will become thicker. Correct again? If only the thickness of the ring were affected, we might think the hole would become smaller. But wait, doesn't the diameter of the ring, both outside as well as inside, also expand? And if so, wouldn't the inside ring diameter be larger than the diameter of the ball? Which then would pass easily through the heated ring. Correct, for that's the case. We'll enlarge this ring and see what happens when it's heated. See that? All of the ring expands, inside diameter as well as thickness. This brings us to an intriguing application of thermal expansion, a make-believe one. Consider a 40,000 kilometer steel pipe that fits snugly all around the circumference of the Earth, and that Earth's surface is flat land all around. Suppose people all along its length breathe on it so as to raise its temperature 1 Celsius degree. The pipe expands. It gets longer. It is no longer snug. Here's a question. How high is the pipe elevated above the ground? To answer this question, you have to know that steel expands 11 parts per million for each 1 degree Celsius increase in temperature. There's a nice shortcut to the solution. Consider only the expansion of the pipe's radial distance from the center of the Earth. Another thing you've got to know is Earth's radius. You can find this from the well-known geometry formula that relates circumference to radius. C equals 2 pi r. I'll jump ahead and give the answer. At the equator, Earth's radius is 6,370 kilometers. So can we say that expansion of this radius, due to the 1 Celsius degree increase in temperature, is 11 millionths of 6,370 kilometers? The answer is yes. Your trusty calculator will show that it's 0.07 kilometers. So the once snug pipe would stand 0.07 kilometers off the ground. That's 70 meters. The pipe would be elevated 70 meters above ground level. That's like the 20th floor of a city building. Astounding. Sure, that 70 meters is a lot, but realize it's only 11 millionths of Earth's radius. Thermal expansion is more evident for big things. Bottom line, thermal expansion is an everyday and vital concern to engineers of all kinds. I want to leave you with a question. Here's a metal ring with a small gap. If you were to heat the ring, would the gap become wider or narrower? Until next time, good energy.